Hello, welcome to another briefing. I just wanted to let everyone know I am in the process of getting a little tripod for support so I don't hold the camera like this because I'm not very good with computer stuff, and I know that there are a lot of whether YouTubers that have that screen with them talking at the bottom, and then they just share their screen on the computer, and I haven't quite figured that out yet, but um, just making it work like this for now. But what I wanted to talk about today is the parade of storms upcoming on the West Coast and how the storm door has really opened. And let me see, I just kind of want to show you. I like to start out with this map generally showing the rainfall rates and mean sea level pressure, but I think it would actually be interesting to start out with a different visualization. Let's look at height anomalies. Let's look at the pressure anomaly at 18,000 feet. In short terms, that's what we're talking about here. And so let's zoom this out a little bit. Let's put the North American view. And so here what you're gonna see, pay attention, these when you have this blue greenish color here, that's a trough. That means that you have colder air spilling down from the polar regions, and usually you have along the leading edge of these troughs you have cold fronts with a moisture tap, which would bring rain and snow, depending on the elevation and temperature profile and such. um, you have precipitation and colder air usually associated with these blue to green troughs, which represent a negative anomaly in the pressure heights. And you have warm spells, heat waves in the summer, warm spells in the winter, associated with these um, red, orange to red colors, the above average pressure heights here. And what we're going to notice here as we put this computer model projection into motion is you see over the next week or so, the West Coast is getting a lot of troughing. I put this full run here. You see a lot of troughs moving through the West that's going to bring cold, unsettled weather. And in the East, you see more of a ridging pattern. Like if you look at the Christmas time frame here, look at this massive ridge out east. It's bringing a lot of warmer air as this trough carves out to the west. And that's really what I mean with the storm door being open, is when the storm door is closed, you have a big ridge out over the west, and that blocks storms and forces them to the north and east, forces them up over the Pacific Northwest and sometimes all the way into Canada. With this pattern, we have an open storm door where the storms are allowed to come in from the Pacific because the jet stream winds are transporting them in as such. And I'm going to show you the jet stream wind map so you can get a better idea. These are the winds at 18,000 feet, and you can clearly see here. I'll even zoom in a little bit more. Let's look at the northwest here. So you see these really strong winds here. This white represents winds over 100 miles an hour at the 18,000 foot level, and the direction is out of the west-southwest here. So that's a very rich moisture tap that's coming in. A lot of dynamics, a lot of orographic forcing where the wind moves up and over the mountains and squeezes out more rain. This is a lot of moisture, and this is a very favorable pattern for storms to come in. This is an open, wide open storm door. The storms are out here, and they're allowed to just come right in as this ridge is way to the east, and so it's not blocking anything from coming in. So let's see here. Let's look back at multi-parameter here. Look at precipitation, pressure, and such. So here, I'm going to show you these systems here. here's our next system. Let's call this one system number 1 into Monday. And then Tuesday night, Christmas Eve, going into... Actually, this is Monday into Tuesday, apologies. This is 23rd into the 24th. This is the morning of Christmas Eve. We're looking at significant rain for most of northern and central California. Unfortunately, these systems are still having a hard time making their way all the way down to Southern California. Really hoping for some weather down there, but of course we weather enthusiasts and meteorologists don't control the weather, we just study it. So anyways, here's system number 2. That's the Christmas Eve system. And then not far behind it, look out to the 26th, here's system number 3. And notice how these are just coming in one after the other with that southwest flow aloft, just bringing everything in, wide open storm door here. System number 4 comes in on the 27th. And then behind that one, we have system number 5 on the 29th. Now, this is just a computer model projection based on the conditions as we best understand them today. This is not a forecast. This is computer model guidance. This is showing signals of what could happen over the next week or so. So this isn't going to be exact timing. This isn't going to be exactly how much rain we're going to see. It's just a projection based on what we know today. This is an idea, a signal, if you will, of what may be to come. So now that we've looked at the long term and we looked to see even another system might come in around the 2nd, but this is looking quite a ways out, so take it with a grain of salt. So what I want to show you now that I showed you the long term, I want to show you the short term simulated radar projection for these next couple systems. We have a pretty weak system coming in tonight, Sunday night, maybe light to moderate rain for most in the Bay Area here, maybe some pockets of moderate to heavier rain, but this thing moves out pretty quick, and you can see from the precipitation totals, this is not very impressive, maybe 1/10 to 2/10 of an inch for north of the Golden Gate Bridge. South and east of the Golden Gate Bridge, trace amounts, barely anything. Now let's go into the simulated radar as we go through Monday, and then as we go into Monday night here, look at that. On the NAM computer model, bringing in some pretty moderate to maybe even heavy precipitation, main frontal band coming through at 4 a.m. on Tuesday. It's incredible how these things manage to always come in the middle of the night. I personally wish they would come during the day, but I can't control the weather. I just study it. So, here's like a few more showers behind that, but look at what happens with the totals after that second system. Way more impressive. You're looking at parts of the coastal hills of Marin up to maybe 3 inches. You're looking at most of Marin County and the big cities around 1 inch, maybe a little over 1 inch for some areas. You're looking at the East Bay, Livermore, maybe 1/4 of an inch, maybe 3/4 of an inch for San Jose. That's pretty impressive for them. Looking at widespread amounts of 1/2 inch to 3/4 of an inch throughout the Bay Area. Santa Cruz Mountains could get 1 to 2 inches per this computer model projection. This particular computer model at this time, that's what we're seeing. That could still change. My guidance is guidance. It's not a forecast. Just remember that. As we get closer, as we get like this high resolution short-term models, we do have a pretty good idea. These numbers usually are pretty good projections, but still can't take it as an exact forecast. Just beware of that. But that's roughly what we're expecting with these next 2 systems that are in range of the short-term high-resolution models. Now, let's look at temperature anomaly nationwide at the 5,000 foot level. This is very interesting. This is a good way to tell what kind of air mass you have at the 5,000 foot level, which does not And the reason we look at the 5,000 foot level is because the surface has a lot of terrain features and also daytime heating and overnight cooling. There's a lot of fluctuation. 5,000 foot level has a lot less fluctuation. It's a better way of having a more solid snapshot of what's happening with the temperature profile aloft, and the air mass movement and such. So, as we go in these next few days, we see a lot of warm air progressing from the western U.S. into the central U.S. with that ridge of high pressure that I was showing earlier. We see this Arctic air mass exiting here. Look at this blast of cold air exiting the northeast. These are 5,000 foot temperature anomalies, close to 20 degrees Celsius below average. I'm not going to get into the technicalities of conversion. It's not really important for this, but I just wanted to show you just this bitter cold air. Just pushing through the east right now, and then we have some warmer air, very warm air. I mean, this is like not summer-like warmth, but this is well above average into even a lot of Canada here, the eastern U.S. pushing way up into Canada with this ridge of high pressure. And then that starts to push out, and then we have another blast of cold air. And by the way, notice even out west there's a lot of warmth. These are very warm storms that are coming in. We have a southwest flow, which brings a lot of subtropical moisture, a lot of warm air with that. And then that warmth starts to push out, and we have another blast of cold air that starts pushing down from the northern plains into the southeastern United States, all the way down to Florida, all the way down to parts of the Caribbean by January 4th. Look at that blast of cold air. Look at maybe 15 degrees below average here. And then look at an even stronger blast of cold air behind that. Look at that. Look at that frigid air. This is Arctic air. This is not even a polar air mass. This is an Arctic air mass that's coming in on this projection for the GFS model. This could still change, still a ways out, but looking really cold for the central US around the January 6th, January 7th time frame. So we're definitely going to want to keep an eye on that. Well, that's all I have for today for this video. I hope you enjoyed it. I hope you were able to get something out of it. Thank you for watching, and I'll see you next time.